Next, we're going to discuss concepts of polyhedrons and the surface area as well as the volume of each of these. We're not going to talk about all of them, we're just going to talk about some of them as well as some other three-dimensional objects. So we're going to talk about rectangular prisms, we're going to discuss cylinders, spheres, as well as the cone. So first off, our objective is to be able to determine the volume and surface area of polyhedrons and spheres given the edges, radius, and slants of the object. So the first thing, what is a polyhedron? So a polyhedron is a solid that is transformed by polygons. Sorry, that is formed by polygons. The plane surfaces are called the faces, and the segments joining the vertices are called the edges. So underneath you can see a polyhedron of the cube. So each of these sides are known as edges, and the flat surfaces are known as my faces. Now, in the volume of a solid, the number of cubic units contained in the interior of the solid is, of course, the volume of the solid. The surface area of a polyhedron is the sum of the areas of the sides of a polyhedron. Now, one way you can definitely figure out the sum of the areas of the sides is to use something known as a net. No, I'm not talking about fission. So, first off, a net is a flat representation of all of the faces of a polyhedron. So it's almost like taking a box of cereal and now opening it and taking all the sides, breaking it apart so it lays completely flat on the ground. That doesn't mean smushing it, that means opening it up. So, for the first, we're going to talk about something known as a rectangular prism. In a rectangular prism, we have three variables. We have the length, we have the width, and we have the height. Some people call it something different. It could be depth, it could be the base. There's so many different names, but we're just going to say length, width, and height. So length, width, and height. Now, easy enough. The volume of a rectangular prism is very, very similar to the two-dimensional. So in the two-dimensional, we discussed that you can have the one multiplied by the other, and so it's just how many layers that exist. Same thing, now we have a third direction of layers. So we're going to now go in the direction upwards. So we have length times width. Now we're going to add on times height. So it's length times width times height for the volume of a rectangular prism. The surface area of the rectangular prism, so it's a little bit trickier. So here we have a rectangular prism. What we're going to do is break it apart and look at its net. To the right you can see its net. We have a large portion, two outers, and two inners. So in reality, we have three different figures. We have two of each figure. So we can have the length, the width, and the height. So in reality, it's 2 times length times width plus 2 times width times height plus 2 times length times height. Let's try one for practice. So here we have a rectangular prism. We're going to say that the length is 10, the height is 8, and the width or depth is 2 meters. So first let's start off with the volume. The volume is equal to just the product of all three. The length times, the height times the width. So length is 10 times 8 times 2. So the volume is equal to 80, 160. So 160. Now, this is in meters. It's not meters squared. We have 3 directions, so it's meters cubed. And that's volume. Surface area, the tricky one. We have to account for all the faces. So first off, let's talk about the bottom and top. The bottom and top are the width 2 times the width and length. So it's 2 times 10 and 2. Now, the next one, let's talk about the sides. Do another color. So we have the sides are the height times the width, and we have 2 of them. So it's 2 times height, which is 8, and width, which is 2. And finally, for the last one, we need the front and the back. It's a little bit more difficult to see. So the front and back is the length times the height. Now, you'll notice that it might be in a little bit different order. It doesn't matter the order as long as you're adding up all the 3 different side groups. So we have 2 times the length, which is 10, times the height, which is 8. So let's multiply it all out. 2 times 10 times 2, 40. 2 times 2 is 4, times 8 is 32. 2 times 10 times 8 is 160. Add them all up, 232. Now, is it meters, meters squared, or meters cubed? You might be thinking there's 3 directions. However, when we broke it up onto a flat surface, which means it's flat, it's only 2 directions. So it's meters squared. Surface area is 232 meters squared. Next figure we're going to talk about is the cylinder. In the cylinder we have 2 variables. We have the radius, notice r, and then we have the height. For the volume of the cylinder, we're going to take the base and the area of the base, which is circle. So the area of the base is pi r squared. And now we're going to discuss how many layers it has. Layers is noted by the height. So it's pi r squared, the area of the base, times how many layers it would have, which is the height. So pi r squared times h. Now the surface area of the cylinder, this one's definitely a trickier one. We have to open up the cylinder, and we will notice that we get a rectangle with 2 circles on both ends. So we have 2 circles and a singular rectangle. Now, easy enough, we know what the area of the circle is, because we know that it has a radius. We also know the height of the rectangle, but the more confusing part is, what exactly is the length of the rectangle? So if I took the circle and rolled it all the way across the rectangle, I would find that the radius creates the circumference, and the circumference is actually the length, which is 2 pi r. So the 2 area circles, so it's 2 times pi r squared, 2 circles, plus the area of the rectangle, which is 2 pi r times h. Let's try some practice. Now, I have a cylinder with height of 8 and radius of 2. Let's start off with the volume. Volume is equal to the area of the circle times the height. So area of the circle is pi r squared times height. Plug it in. Pi times 2 squared times 8. That's 4 times 8 is 32. I get 32 pi. Since it's volume, 3 directions, it is centimeters cubed. Now the next one, this is the tricky one, surface area. Surface area is equal to the 2 circles, 2 pi r squared, and then the area of the rectangle, 2 pi r h. R was 2, h was 8. So 2 pi r, 2 squared, plus 2 pi times 2 times h. I have 4 8, 8 pi, plus 2, 4, 32 pi. Now, because they have both be multiplied by pi, I can add them together. 8 plus 32 gives me 40 pi. Make sure I keep the units. Centimeters squared. 40 pi centimeters squared. As of right now, it seems to be a pattern that all the surface areas are larger than the volumes. That can be true. Doesn't necessarily always have to be true. Next one. Sphere. In a sphere, this is the nicest one. There's only one variable. So we have the radius. Singular variable. So the volume of the sphere is this one you just got to memorize. 4/3 times pi r cubed. And also the same deal with the surface area of a sphere. If I try to take the net gives me this. And we have not learned anything to take care of all of the individual areas. We don't know how to find any of them. So the surface area I'm also going to give you, which is 4 pi r squared, which is similar to saying that the sphere is the same as 4 times a circle. Now, an example problem. We're given that the radius is 9. What we need to do is find the volume. Volume is equal to 4/3 pi r cubed. With 4/3 pi, we have 9 quantity cubed. So what we have to do is take 9 cubed gives me 729. 729 divided by 3, 243 times 4 gives me 972 pi. You need to make sure you multiply the numbers first and then add on the pi. Try not to throw everything in at once in the calculator. Also be very careful when entering these values in the calculator. When I enter it into the calculator, I must do 4/3 pi, put in the multiplication sign, and then say 9 cubed. If you don't put in the multiplication sign, you will get a syntax error. So it would be 972 pi meters quantity cubed. Now let's do surface area. Surface area is equal to 4 times pi r squared. Again, we said r was 9. 4 pi times 9 squared. 9 squared is 81. 81 times 4 gives me 324 pi. And in this case, we can actually see the surface area is less than the volume. Now, last one we're going to talk about is the cone. How in the world am I going to be able to figure this out? The volume and the surface area. First, we're going to look at the 3 different variables. We have the radius, we have the height, as well as the slant. Mark them. This is the radius, the height, and now the slant is the distance from the very, very tip of the cone all the way down to the very, very bottom, or one side. So the volume of the cone is actually almost exactly like the volume of a cylinder. Only difference is it's 1/3 of that value. So it's 1/3 the area of the base, which is pi r squared, times the height. So it's 1/3 pi r squared times height. Now the surface area of the cone. This one looks a little bit trickier. We took a net of that. So that part's really easy. Pi r squared. This section, on the other hand, is a little bit trickier. So here we can actually note this all as pi r squared plus the value of pi rs. Let's try practice. So we have the slant of 5 We have the height of 4, and then we have a radius of 3. The volume is equal to 1/3 the base, pi r squared, times height. So in the volume, don't even need to know what the slant is. So I'm going to say volume is equal to 1/3 pi, radius is 3 squared, and height is 4. 9 divided by 3 is 3, times 4 is 12. So it's 12 pi centimeters cubed. Last thing, surface area. Surface area is equal to pi r cubed plus pi r squared. So in this, we just plug in the values. R is 3, so pi r times 3 times s, which is 5, plus pi r squared, pi times 3 squared. And in this case, we don't even need the height anymore. 3 times 5 gives me 15. 15 pi plus 9 pi. We get 24 pi centimeters squared.